Today our goal is going to be to compare equation mats, taking a left side of an equation mat and comparing that to the right side. A lot of times we call the left side would be an expression, the right side would be an expression, and when we combine those with an equal sign or an inequality sign, that becomes an equation. So let's take a look at how we can combine. But before we can do that, we need to know some principles. And what these are called, they're called zeroing out principles. So for example, if I were to take a positive unit tile, what would zero that out? Well, if I also had a negative unit tile, that's like having positive 1 plus negative 1. A positive 1 and negative 1, those cancel out. Well, there's another way we can cancel out. Another way we could do this is if we had a positive on the top and minus 1 on the bottom, right there. A positive 1 minus 1, well, 1 minus 1 would be 0. So that's another way. Another way we can zero this out is if I had 1 on the left side is equal to 1 on the right side. Well, in order to get rid of this 1, I would need to subtract 1. But whatever I do to one side, I must do to the other. So if I subtract 1 from both sides, you can see that we zero out. So without bringing these down here, you should be able to see, there we go, that this side and this side, if they're on both, if it's the same term on opposite sides, they will cancel each other out as well. The last one, which is the most complex way, okay? This one would be the one that probably takes the most thinking. If I have a positive 1 on the left side and a negative and minus a negative 1 on the right side, well, what does minus a negative 1 equal? Think about that. Two negatives, a double negative actually makes a positive, so these two could cancel. I don't know that I would suggest doing it that way. The way I might suggest doing this is, well, before you do this, you zero that one out. Whatever you do to the top, you must do to, or whatever you do to the bottom, you must do to the top. So these two zero and cancel each other out, so they're gone. So that creates a positive on the top. Now you know that a positive on the right and a positive on the left will cancel each other out. So let's go a little more complicated now in this whole thing. So what if we did a couple positives up here, we take an x term up here, we take a negative x term down here, and we take a positive x term down here, and we take another positive x term, and let's make one more positive x term up here, and let's throw a negative x term up here, a positive x term up here, another positive x term up there, and we'll throw a couple more units down here. 1, 2, 3, and this one. All right. So let's go through how to simplify this first of all. Let's first try and just simplify this left side here. Okay. I've got on this bottom side here, I've got a positive x and a negative x. What will those two do to each other? Cancel. So we'll get rid of them. Then I've got a positive x on the top minus a positive x on the bottom. So these two here will do what to each other? Cancel. So we'll move those two out of there. Now nothing over here will cancel. The x won't cancel. So this side is left with x plus 2. Let's check over here on the right side. Well, let's see, I've got a positive and negative together, so those two will do what to each other? Cancel. So far I've got an x plus 1 on the top, but let's look down here. I've got a positive and a negative. What will these two do to each other? Cancel. So we'll move those out of there. We also know that a positive on the top and a positive on the bottom, once again, is 1 minus 1. Those will cancel, so we can get rid of this one. So I'm left with x minus 1 on this side. Let's kind of move everything to the top. So I'm going to put a negative down here and a negative up. Whoa, did not mean to do that. Sorry about that. And a negative up here. Whatever I did to the bottom, I must do to the top. That means these two here will cancel out. And so my left side of the expression mat is x plus 2. My right side is x plus negative 1. Well, the x's from this side and the x from this side will do what to each other? That's right, they cancel out. So the real question becomes, what's greater, positive 2 or negative 1? And if you're thinking to yourself positive 2, then you're bright and you got it right. All right, let's try one more quick one here. I'll use some similar things here. 1, 2, 3, 4. 1, 2, 3, 4, 5. Let's just use them all in whatever order this seemed to kind of come out here as. This all just seems very fun. All right, let's see what happens in this one. First thing is, let's take care of the left side. Well, let's see, on the bottom here I've got a positive x and negative x, so those two will cancel each other. Then from the top to the bottom I've got two positive x's, so these two will cancel each other. Which leaves me with the left side of just two positive unit tiles. On the right side, these two will cancel each other. And these two will cancel each other. And then on the top, these two will cancel each other. So on this one, I'm left with 2x plus 1. On the left side, I've got just 2. So the question becomes, what's greater, 2x plus 1 or 2? And your answer on that one is you can't determine that. And the reason is, let's say that x was 10. If x equaled 10, then 10 plus 1 would be 21, and 21, as you should know, is far greater than 2. But what happens if x was negative 10? Well, now we've got negative 10, and negative 10 makes negative 20. Negative 20 and 1 makes negative 19, which is far less than 2. So, in order for us to be able to compare these sides and tell which is greater or not, the x's on both sides, for example, if it had ended up being this way, the x's on both sides must be the same, so we are able to get rid of them. If they're the same on both sides, then we can get rid of them. Then we can compare the mats. 2 is greater than 1. But if the x's on both sides are not the same, then you cannot determine your solution. Hopefully this helps you out. We're going to be going through a lot of these problems here tomorrow in class, and look forward to seeing you then. Have a good night.